Hey guys, and welcome to the last video of Unit 4. Alright, so now we are looking at lines in the coordinate plane, continuing basically the discussion that we had prior. So we basically looked at I can write and graph equations of lines in slope intercept and point slope form. Now what we're going to do is determine if lines are parallel, perpendicular, intersecting, or coinciding, and also be able to write the equation of a line um, that is parallel or perpendicular to a given line that goes through a certain point. So we're going to dig deeper down into our algebraic skills, connecting it back to the parallel and perpendicular lines that we looked at in 4.3 through 4.5. So we're focusing on 4.6b and 4.6c today. All right, so there's 4 different types of pairs of lines. So we've looked at angle pairs before. Now we're going to look at line pairs. And so we have parallel, intersecting, coinciding, and perpendicular. So parallel lines have the same slope, but different y-intercepts. So see how these are different? Intersecting lines have different slopes. They can have the same or different y-intercepts, but they for certain have different slopes. Coinciding lines have the same slope and the same y-intercept. And then lastly, perpendicular lines have negative reciprocal slope, and the y-intercept can be the same or it can be different. It doesn't matter. A note about coinciding lines are lines that coincide are the same line. They're the same line, but the equation may be written differently. So it could be that one equation is in standard form and the other equation is in point slope form. And when you put them into slope intercept form, you find out that they're actually the same line. So coinciding lines are basically the same line. All right, so we have 4 examples today, and let's get started. All right, so determine whether the lines are parallel, intersecting, or coinciding. So hint, they are not perpendicular. We start off by solving both equations for y to find the slope-intercept form. So we're going to find the slope-intercept form for both of these equations. So we're going to add 4x to both sides and divide both sides by 2. And we're going to get that y is equal to 2x plus 8. So all we did was transfer this into slope-intercept form. Next, we have this in point slope form. We're going to transfer it into slope-intercept form as well. And you might be saying, well, I already know that the slope of this line is 2 and the slope of this line is 2. So they're parallel. Well, all we know so far is that they're not intersecting. So we can cross that out. But we're not quite sure whether they're coinciding or intersecting, coinciding or parallel. Because if they have the same y-intercept, then they would be coinciding. But if they have different y-intercepts, then they would be parallel. So if we do this out, if we do the distributive property on the right side, and then add 10 to both sides, it turns out that we get the same equations. So these lines would be coinciding. Since they both have a slope of 2 and both have a y-intercept of 8, these lines are coinciding. Oops. Now let's take a look at another 2 lines. 3x plus 5y equals 2, and 3x plus 6 equals negative 5y. Are these parallel, intersecting, or coinciding? So, first step is to transfer them or convert them into slope-intercept form. So, just how we've always been going from standard form to slope-intercept form. And we get y equals negative 3/5 x plus 2/5. Same for over here. And we get that y equals negative 3/5 x minus 6/5. So are they parallel, intersecting, or coinciding? Well, they're not coinciding because they have the same slope. Sorry. They're not coinciding because they have different y-intercepts. They're not intersecting because they have the same slope. So since they have the same slope and they have different y-intercepts, these are parallel. Both lines have the same slope but different y-intercepts, so the lines are parallel. All right, so now what we're going to do is we're going to find the equation of the line that is parallel to y equals 2x plus 3 that goes through the point 4, 6. So to get kind of a sense of what that would be on a graph, is that if we made a little graph, we know that we have y equals 2x plus 3. So 1, 2, 3. We'll go 1, 2, 3, 4, 5, 6. And then 1, 2, 3. Okay, so we know that it starts at the y-intercept is 3, and it goes up 2 over 1. Up 2 over 1, kind of like this. So we have the line, and so we're trying to find a line that is parallel to this line and that goes to the point 4, 6. So basically a line, what would be the equation of this line? Okay, so that it's parallel to this line and goes to this point, 4, 6, all right? So that's our goal. So to do this, what we'll need to do is parallel lines have the same slope. So the slope of this new line is going to be 2. We therefore have the slope and a point of this line. So we know the slope is going to be 2, and it goes to the point 4, 6. So we can put it into point slope form. M would be 2, x1 is 4, y1 is 6. So we get this equation would be y minus 6 equals 2 times the quantity of x minus 4. If we wanted to put it into slope-intercept form, we could. We could do the distributive property and then add 6 to both sides. But this is an equation of a line, so we could stop right there. All right. And then lastly, the last thing that we're going to do today is find the equation of a line that is perpendicular to y equals negative 2x plus 3. That goes to the point negative 3, negative 5. So on a graph, we have graph, boom, boom. And so the y-intercept is 3, 1, 2, 3. And the slope is negative 2. So go down like this. Oops, where's my point? There we go. Oh, yay. Goes down like, whoops. Goes down like that. And so we have this line, negative 2x plus 3. Whoops. That's a line. Pretend that's a line. And then, but it goes through the point negative 3, negative 5. 2, 3, 4, 5. So it goes through this point. So basically it's going to be like this line. It's, oops, just kidding, not that line. We're doing perpendicular. So it would be this line. That's what we're looking for. All right, what's the equation of this line? It goes through this point, and it's perpendicular to this line. All right, so we know that perpendicular lines have negative reciprocal slope. So since the slope of this line is negative 2, the slope of the line that we're going to try to find is 1/2, positive 1/2. We therefore have the slope and a point of this line that we're trying to find the equation of. So the slope is going to be 1/2, and the point is going to be negative 3, negative 5. So we have m, x1, and y1. So we'll get that y minus negative 5 will equal 1/2 x minus negative 5. Oops, this should be negative 3. This should be negative 3. 3. So that we'll get that y plus 5 is equal to x plus 3. X plus 3. Okay. And with that, we are done. There's an online quiz for 4.6, and then we are on our way to finishing up this unit. Thank you, guys.